Okay. On the question paper, as jy kort kan jy daar voor lê. Jy was hier. Okay. Janneke het nou gevra vir 4.2. Zimakazi, which one do you want me to focus on? Okay, so I'm going to do the whole question 4 and the whole question 5 with you guys quickly. Just quickly for question 1, if I ask you for the first 3 terms, hello, you just substitute 1, 2, and 3 in. Het julle gesien? Nee? Hello? Okay, so that is maklik. Some of the first 8 terms you could continue. 4, 5, 6, 7, 8 and then add them together. Or you could find the rule and substitute it into the sum of formula. Daai is 'n meetkundige reeks. So jy kon hom sy A en sy R gaan uitwerk het en by hom uitgekom het. Then number 2, they give you a sequence there. I think it's a quadratic sequence. Yes. Write down the next 2 terms and determine the sum of the first 100 terms. Is it a quadratic sequence? No, sorry. Do you guys see it goes 5, 4, 5, 11, 5, 18, 5, 25. So in other words, you are actually only looking at the 4, the 11, the 18 and the 25. Nee? En hulle maak plus 7 plus 7 rekenkundige reeks. Okay. So you're going to say the sum of the first 50 of that plus 50 times 5. Do you guys agree? To get the sum of the first total 100. Then they say they give you a series where it's divided by 3 each time. So times by 1/3. Find the formula for the nth term, so that'll just be 54 times a third to the power of n minus 1. Show that the sum of the first n terms will be given by that. Did you guys manage 3.2? That's quite a difficult one. Do you want me to go with it through with you guys? Okay. Okay. Did you guys find for 3.1 Tn is equal to 54 times a third to the power of n minus 1? Good. Good. And then they say, oh, guys, remember to study your formulas, no? All of your formulas. Because you're not getting, you don't have a crib note. Van die Junie-vakansie af. If I remember correctly, there's not one in this. I'll ask, but the answer is going to be there's not one in this. Can you convince you? No, I'm not a very convincing person. Okay, so that you have to actually study, né? Want anders dan gaan jy nou nie weet dat hierdie is 'n meetkundige reeks en ek soek die som van, so you have to go study that. Okay, let's substitute. 54 a third to the power of n minus 1 over that. You don't have it? No. Okay, and then this simplifies to y is negative 2 over 3, that's negative 2 over 3, this part. And if you say 54 divided by negative 2 over 3, it becomes negative 81. En dan as ons hom inmaal, dan is hy by daai antwoord. Okay. Then for 3.3, what does that tend towards if n tends towards infinity. So hulle vra vir my, wat gaan daai getal wees as n neig na oneindig? Now, the answer is simple, but I'm going to show you guys why. That is actually a graph. Do you guys remember that graph? It's an exponential graph. Okay? Hy is nou net nie in terme van x en y, hy is in terme van t en n. So do you guys agree this, as it moves towards infinity on this, on the y-axis or on the tn axis, it's actually moving towards 0. It tends towards 0. Okay. So jou antwoord is 0. As jy 'n ander manier soek om dit te doen, as jy op jou sakrekenaar gaan intik 'n derde tot die mag 100 byvoorbeeld. Ek weet nie of ons sakrekenaars dit kan doen nie. Hy sal kan, want hy gaan hom net as 'n wat die woord wiskundige ding gee. So it says this is equal to wetenskaplike daai ding, notasie. Daar is die woord. Okay. So this is 0,0000000. I'm not going to write all of them. 194 with a lot of zeros there in the middle. So that's basically 0. The bigger the number becomes, it's going to become even smaller. So as it is tending towards infinity, your answer is tending towards 0. But it's almost easier to understand it with a graph. Onthou op 'n stadium gaan ons net sê dit is nou so naby aan 0, dit is 0. As ons na hierdie werk differentiasie vergelykings gaan doen, gaan ons ook doen hierdie neigings. En daar gaan ons sê h neig na 0 en op 'n stadium gaan jy dan sê, okay cool, h is nou 0. So dan stel ons hom in. Okay. Hence determine the value of that. So in that case, the sum to infinity, we've already written down. Oh no, let's do it like this. Sn het ons klaar gesê is 81 minus 81 maal 1 op 3 tot die mag n. Guys, I'm not getting a formula page. I asked on the group. So dit sou ek ook vanmiddag gedoen het dan, in my een dag wat ek het om vir wiskunde te leer anders. Okay, group them together. Like, say, for all of your arithmetic sequences, you have Tn is equal to a plus n minus 1 times d. You know that T2 minus T1 is equal to T3 minus T2. You know you can calculate D by subtracting those from another. Wat's er nog? You know that the sum formula... Dankie. I think that's all of them. Infinity is by die ander. That's with a geometric sequence. Okay, maar dit is eintlik hierdie. Ja, there's another Sn. Wanneer jy die laaste term het. As hy die laaste term vir jou gegee het en die eerste term gegee het, is hy maklik. Hy gaan altyd werk. Ek gebruik hom altyd want dit is maklik. Okay. And then you do the same with a geometric sequence. So you write them down. Tn is equal to a times r to the power of n minus 1, etc., etc., etc. And then when you are writing and you see, okay, I'm busy with a geometric sequence, then no, it means I'm using this. It might also be worth your while to actually in the beginning of the test write your own little formula sheet. I would actually do that because then you're not under pressure to do it. So gaan skryf hulle vir jouself mooi uit vanmiddag. And then tomorrow when you start writing, maybe start by writing down your formulas. Luckily, the geometry doesn't have any formulas for you to study. Nee? Dis mos nou net toepassing. Yes, you are writing geometry tomorrow. Don't tell me that. I don't want to know that. All of you know what you're writing on tomorrow. Let me just live in the ignorance that you guys have studied hard already. Thank you. All of them together are called number patterns. Yes. Ja, en graad 11 meetkunde. So, die graad 11 werk wat jy moet oorbring hierdie kant toe is by die ry en reekse kwadratiese formules, né? Nee? From sequence and series from last year we have quadratic. And for that, remember this, you should probably study. Okay, go study that. That will anyway never be on the formula page, so you have to know that anyway. So that's the big thing that comes over from grade 11 sequence and series. Okay, then in grade 12 sequence and series we did geometric, arithmetic, sum to infinity, and sigma notation. Ne? Okay. But the sigma notation is actually just application of the other two. Ne? And sum to infinity is also just a type of geometric sequence. It's just a geometric sequence that converges. Ne? Okay, so daai twee is die twee hoofgoeders. Jy het kwadraties, rekenkundig, meetkundig. And then some applications of that. And then with the geometry from grade 11, you have to bring over all of your circle geometry. So dit beteken julle moet weet hoe om te bewys dat iets 'n koorde vierhoek is, hoe om te bewys dat iets 'n middellyn is, hoe om te bewys dat iets 'n raaklyn is, and all of those where they like to ask name 4 angles that are equal to x with reasons, né? Nee? Daai goedjies en al jou goeders kan toepas, jou raaklynstellings, jou koorde vierhoekstellings, middelpuntstellings, angles in the same circle segment. Don't forget about your, I almost want to say easy geometry. If you have two radiuses, then that's an isosceles triangle. You can always use that. If they give you parallel lines, they're probably going to ask you some alternating or co-interior angle or something like that. Okay. Yeah. Yeah. And then in grade 12, it's the proportionality theorem. The similarity, how to prove the similarity, those two ways, and then the Pythagoras one. But remember the Pythagoras one, you can always just use one of the similarity ones. It's if you have a triangle with a 90-degree angle and you draw a line, and you draw a line, then you have three triangles, all three of them similar to one another. Ay, 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 ay. Then poor me. If we got paid according to our effort, millions. Okay, goed. Kan ek aangaan gou?